As part of my Heathkit square sine wave generator restoration process, I wanted to rewind the power transformer to 230 volts for easier use here in Europe. In this video I will show you step by step how to disassemble a transformer without damaging the laminations and other parts you can reuse. All transformers use the cloth covered wire, which is usually easy to pull down, but in this case it was so stiff and brittle that I had to use a knife to remove it. Before taking the transformer apart, I wanted to check the no-load voltage, so that I can rewind it as close to the original as I can. Being very careful not to touch any of the leads while the transformer is on, I connect the voltmeter to each of the leads and took the readings at 115 volts on the primary. Now it's time to disassemble the transformer. The end bells were held by only 2 screws on the side, so I took my flathead screwdriver and removed the 2 screws. The end belts here just fell apart easily, which sometimes might not be the case. If you're having a hard time removing the end belts, just pry them off gently with a thin blade or a screwdriver. Once you see the exposed coil and the laminations, give the whole transformer a good overall look and check if there is anything unusual about the way the transformer was put together. For example, this particular transformer had small wooden wedges to help secure the bobbin to the laminations. That means that we would have to drive out the wedges before attempting to remove the laminations. Also, there are 2 metal laminations at the ends which also serve a similar purpose of securing the laminations. Take a knife with a relatively sharp blade and slowly and gently try to lift each of the ends by sliding the blade between laminations. Be careful not to have the knife slide through and cut the bobbin. Once you have it loose, it's time to get the wedges out. I use a couple of flathead screwdrivers and gently tap them from different angles and sides until they start moving. Take your time, since this might be tricky and drive you crazy. After the wooden wedges are out, you can now very delicately start tapping on the laminations. Try giving each of the 3 columns equal taps until you see them move. Don't rush or pull the laminations too hard, since they are thin and will bend and become unusable easily. Once you have one out, just continue repeating it and applying the same technique over and over. Avoid X-Acto knives or other thin blades because they might break, chip off and fly back to your face and hurt you. If you're fully unwinding a transformer, be very careful not to get carried away and cut the bobbin or any of the exposed leads or wires. This is only a power transformer, so there is no need to fully unwind it, since no complex winding method or techniques were used to wind it. For rare output transformers, you would want to be even more delicate and use more complex techniques to be able to unwind each of the windings. Here I will just show you the overall look of the winding, and I will unwind the filament winding since it only has 28 turns. You could also measure the thickness of the wire and laminations used, the number of laminations in the bobbin, and the dimensions of the bobbin. Even with simple power transformers, it's interesting to see how they put the transformer together. Here you can see how the ends of each winding were secured and soldered to the lead wires. The layers are perfectly wound. Since I'm not planning to use the original bobbin, I will not unwind all of the layers. I will use the plastic bobbin with a similar dimensions and just reuse the laminations and the end bells. To calculate the number of turns, I'm using my simple power transformer calculator spreadsheet. I've designed it so that it automatically calculates number of turns and thickness of wire for each winding. It's extremely effective and cannot be easier to use. If you would like to support the channel, you can follow the link in the description and purchase this spreadsheet along with a short PDF tutorial explaining how to use it. The calculations and tutorials for calculating output transformers are also available. So I just select the core size I'll be using, then set the voltages for each winding and their current ratings. Since this is a voltage doubler circuit, I've used different wire thicknesses for the primary and the high voltage winding than you see here in the video. You can also notice that the 230 volt transformer requires more primary turns, and also the fact that we use 50 Hz instead of 60 Hz makes that into even more turns. I wound the new wire to the bobbin as per calculations. You can check my other videos to see how I wind the transformers. I'm in the process of building a new automated winder and also changing the way I use the manual one. That's why please excuse the crude look of the present winder in action. The end bells were pretty rusty and the stands at the bottom were a bit crooked. So I cleaned them and sanded them, removing the rust using a wire wheel on my drill press. You can see that it looks a lot better once you sand it properly. I will apply a couple of fresh coats of glossy black paint to protect them from rust. Once the paint cured, I reassembled the transformer using the newly wound bobbin, old laminations, and renewed end belts. Hope you've liked this video, gave it a thumbs up, and subscribed. April is definitely a great month to like my videos and become a patron. Thanks for watching and for your support.